to the participants for coming to the ARNECC Paper Talks. We are waiting for another 3 minutes as we will wait for other participants to come to the discussion. Thank you so much.
Good afternoon to Dr. Nabila and also to the participants. If you are already here with us in the Zoom room for the fifth episode of our next Paper Talk, we will shortly begin the session today. And good afternoon again. So welcome to the fifth episode of our next Paper Talks. Our next Paper Talks serves as a platform to hold regular discussions among scholars and academicians for published papers and articles on energy and climate change in Southeast Asia. ASEAN Researchers Network on Energy and Climate Change, which is what ARNECC is a group of scholars, analysts, researchers, students, and other stakeholders organized around the themes of energy studies or research and climate studies or research in ASEAN. This discussion platform is established by the ASEAN Climate Change and Energy Project, or ACCEP, and my name is Veronica, an Associate Research Analyst of Sustainable and Renewable Energy Department from ASEAN Center for Energy, who will lead the discussion for today's event. And on this special occasion, the fifth RNA aims to bring forward a study that discusses a particular model for net zero emissions in the palm oil industry. In my humble opinion, us in Southeast Asia are quite familiar and accustomed to palm oil discussion. And palm oil discussion and palm oil itself has become one of the most sought after commodities due to its versatile use, being used as the ingredient for a wide variety of products, ranging from food to cosmetics. In fact, this versatility has made palm oil an integral part of everyday lives in the society. As an illustration, palm oil accounts for 40% of the total global consumption of vegetable oils. And this coupled strengths of demand and versatility of palm oil has made it an incredibly lucrative crop to plant. Uh, ASEAN countries are currently one of the largest palm oil producers in the world. And the rise in meeting global palm oil demands is reflected in the expansion of large palm oil plantations across the region. And however, the expansion of palm oil industry is also associated with negative environmental impacts. And today we have Dr. Nabila Farhana binti Jamaluddin, who is a lecturer at the Chemical Engineering Department, University Technology Petronas of Malaysia, and a research fellow at the Center of Advanced Process Safety, Institute of Smart and Sustainable Living. Dr. Nabila specializes in carbon footprint assessment, sustainability index, and optimization models. And she conducted her PhD project on the integrated carbon and sustainability assessment framework with a mitigation strategy model using GAMS. We will have a very exciting opportunity to listen to Dr. Nabila Farhana talking about her journal article, A Holistic Mitigation Model for Net Zero Emissions in the Palm Oil Industry, and which is co-authored by Dr. Nabila and her fellow writers. Okay, so good afternoon, Dr. Nabila.
Good afternoon, Vero.
Yeah, it's very nice to see you. How are you?
Yeah, I'm good. How about you?
Yeah, I'm great as well. And would you like to share a brief teaser on what you will be talking about? Like
Okay.
just
Okay, so for today, I will talk about my recently published article, which is regarding how do I develop the mitigation model in order to in helping to achieve the net zero emission and something like that. Yeah.
Oh, great. Sounds very exciting. Now, not to prolong this chit chat, I would like to invite Dr. Nabila to present the material. Please, Dr. Nabila, the time is yours.
Right. Thank you, Vero, for the introduction. Give me a minute to let me share my screen. Okay. I hope you guys already can see the full screen.
Yes, I can see your post.
All right. So it's good. Okay. I think let me start. Yeah. Okay. Hello, everyone. Good evening and Salam Ramadan to those celebrating it. First of all, would like to say I'm so honored to be invited by ACE to share my recently published paper into this webinar. Okay. Without wasting any time, let me start my presentation. Okay, so this is the title of my presentation, which is a holistic mitigation model for net zero emission in the palm oil industry. Okay. Okay, next slide. Okay. Okay, so this is just the sharing session outline. I will start with a brief introduction of the research background. Then I will continue with the overall methodology. And after that, I will zoom in into the model development methodology. Then I will show you the results and discussion, and lastly is the conclusion of this study. All right, so as been introduced by Vero just now, she's been talking about that Malaysia and also Indonesia, I think one of the biggest producer for palm oil meal. So I believe that in alignment with the net zero emission aspiration, I think both of our government has implemented policies and many initiatives to promote sustainable palm oil production. So indirectly will also helping to reduce the emissions. However, up to the current date of the study, still remains a need for a comprehensive and also an integrated mitigation strategy as a support tool to optimize this palm oil meal performance. Okay, I will say that the current palm oil certification scheme or maybe other palm oil assessment and also other guidelines is still lack of the uh, support tool to help the industry to for them to do I mean to optimize their operation. Okay, so by having a good mitigation strategy, it will help reduce the emission hopefully. Okay. Okay. All right. So in this sections, actually this is the overall methodology, okay, which structured into 5 main parts. Okay. So we have here part 1, the details. You can see at the left side of the flow chart. It shows the details of the development of palm oil mill carbon footprint assessment, which can be shortened into POMCFA, which emphasize the quantification and reporting of carbon emission from the mill. And then if you can see at the right side of the flow chart, it shows the development of the POMSI, palm oil mill sustainability index, okay, which focusing on the quantify and report the sustainability performance in alignment with the any standard or national guidelines. Okay, and then if you can see at the bottom one, bottom part of the flow chart, we have part 2 and part 4 shows the analysis of the from the analysis from the POMCFA and also POMSI conducted to identify the weaknesses which this analysis will be used into part 5 in the center. If you can see in the red, the one that I make a box in a red. Okay. So actually in this study, our primary focus is on part 5, which is to establish the integration of the mitigation strategy planning with the result that we have from the POMCFA and also POMSI, right? So if you are interested on the part 1 until 4, you may read the more comprehensive explanation and details in my previous published article as shown in the left side of the slide lah. Okay. Okay, now since I'll focus on the part 5, so let's zoom into that part, which is model development, as you can see from the slide. Okay, so this section present the integration of mitigation strategy selection with the which integrate the POMCFA and also the POMSI assessment. So by having that assessment first, it will provide an overview of the development of the mitigation strategy selection tool, selection model for both of the assessment. All right, so the study will consider a set of mitigation strategy that can be potentially can be implemented to improve the weak indicators, which we identified from the earlier assessment, which is from the POMSI and also POMCFA. Okay, so based on that result, then we will after that we will analyze it, and then how do we identify which mitigation strategy that will be the most effective to improve that performance. So that that's why we need to develop a superstructure that features several mitigation options to improve the indicators. Okay, right. So after we have developed the superstructure, okay, the next step is the mitigation strategy selection. Focus on the data gathering from the existing POMCFA and also POMSI database. Okay, and the data particularly will be retrieved from the recent study, from the literature review, so that we can decide the factor changes of that mitigation to the indicators in the POMSI and also POMCFA assessment. Okay. And then the next step, the mathematical model will be developed to develop the mitigation strategy selection model for POMCFA and POMSI will be formulated lah. Okay. So this model were formulated according to the superstructure that been developed earlier. That later will be coded into camps, and then from that finding, we will verify it using a case study. Okay, and then the result we also will use that to simulate a new score for POMCFA and also POMSI assessment in that assessment. Okay, right. So this is the model development methodology. Okay, here here we go to the I think this is the result and discussion section. Okay, as highlighted before, a framework to assess the performance of the palm oil will be developed. Okay, so if you can still remember that just now I mentioned about the result from the POMSI A and also POMSI. So this is what it will be look like. Okay, so first we can see that we can see that the first identify hotspot, which is we find from the assessment, the lowest score is for the indicator mixed raw effluent, which is I think not the lowest, but one of the lowest indicators compared to other indicators. So this is where we need to pay attention, or this is where we need to do the improvement lah. Okay, so it's on the score of the sustainability index is only 50%. Okay, so it's not very good. Okay, and then also you can see the CO2 equivalent emission is 13.25 CO2 kg in kg. If you compare to other indicators, this indicator contribute to the highest emission. Okay, so here is where we need to improve our indicator. I think this is the part that we need to pay the attention lah. Okay. All right. So how do we how do we address that? How do we improve that? So this is where the superstructure come in. I mean, the model will help to the user or maybe to the plant to help them to making a decision, making a more informed decision, which mitigation will be most appropriate to improve that issue. Okay, so if you can see here, this is just a general superstructure. You can see that we need to include the mitigation option, and then how the how the mitigation option will affect to your indicators, and after that we can calculate lah the new index based on the proposal. Okay. Okay, here, before we proceed with the model, so we need to have a technology review, which will be, this is like a back calculation for the model equation, the model development. So we need to have this database first, which we will to find any relevant mitigation strategy and a mitigation strategy that can which is relevant to your industry lah. Okay, so for example, this one we have like 22 mitigation strategy that been finalized. So each mitigation strategy has different impacts to the indicator. So so how do we develop this database? In this study, we only consider the data from the literature review, and then maybe from the articles, maybe from the report. But later on, maybe later on for further advancement or enhancement, we can also include maybe a real case scenario from the industry. So then we can include the mitigation strategy, I would say, information also in our model. All right, so here we go to the mathematical equations of the model. So for this one, we need the objective function, obviously, for the models, and then we have to define our constraint. Okay, if you can see from the first block of this slide, okay, we have our objective function. Okay, so this objective function was derived to select the minimal cost incurred by the mitigation strategy. And then the next box is we consider I would say the investment cost, the production cost, and also the variable costs that will be that will reflect to your mitigation strategy into your constraint here lah. Okay. And then sorry, the indicator requirement for each of your I would say indicators. Let's say for example, your indicator just now got like a 50% score. So for example, your plant or maybe your company want to increase it by 20%. So you can set your requirement into the constraint here. All right, so that's that one is for the constraint. Just now, the earlier one is for your objective function, which is you have to set your you have to determine your cost lah. Okay, and then the last box is the mitigation technology, because we know that some of the mitigation options they serve a same purpose. So for that, we will categorize it into one cluster, and then we transform it into this constraint. So then the model will understand that for any mitigation option that belong into the same cluster, the proposal will be cannot be redundant lah, or they can only select one one from each cluster. Yeah, something like that. So that's for that constraint. Okay, so when we have already set our objective function and also constraint. Okay, here is for the data that will be will be the input for the our model, which is the data for mitigation strategy factor changes, which mean that for each of your technology review or your mitigation option, that will bring some impact to the we'll say to your indicator. So maybe some of the mitigation option give no changes to your indicator, so you can put it's just null. Okay, but if it's bring like a positive change to your indicators, then you can use this the positive changes equation into your database. And then for example, if your mitigation option give a negative change to your indicators, then you can use the second equation. Okay, so it depends on the the characteristic lah of the mitigation option that you found. Okay, so basically, just now I talk about the mathematical model development. So based on after that, then you can compute it into any software. But for us for this study, we use the GAMS, which is the General Algebraic modeling system. So we I would say compute all the I would say the mathematical equation into that software. So based on that, uh we get this as our result. The software I mean propose that the best solution to our issue just now, I mean the one that I presented just now, is a biogas plant and also wet scrubber. So these two, based on the criteria that we've already put, the objective function, also the constraint. So this is the optimal, I would say the optimal solution to our case. So the result shows that the biogas plant and also the wet scrubber. Right. So after this, I will show you how we verified and also validate our data here. I'm sorry, the result here. So we presented into in a different scenario. So just to see the changes if you implement this suggestion lah. Okay. Okay. Now this is the first scenario where we consider to implement both of the I would say the suggestion from the not suggestion, the result from the GAMS, which is we will implement the biogas and also the wet scrubber. Okay, so from here if you can see okay, the blue one sorry, the blue one is the I would say the score before the implementation of any mitigation options, and the orange one is the after mitigation score. Okay, and then you can see the line graph. The purple one is the sorry, the green one is the total of emission before the implementation of the mitigation alternative, and also the purple one is the after the implementation. All right, so if we can compare, if we implement both of these mitigation option, we can see that the firstly you can see the total POMCFA before is 13.82. Okay, so after we implement these two mitigation option, we get it as our total POMCFA is only 11 kg of the CO2e per ton of FFP. Right, so we can see that like I think this is per ton of FFB. Usually the normal or the usual operation, I mean for the industrial scale of palm oil mill production will be very huge. Also if from this value we can see only like a slightly reduced, but if you implement into industrial scale, it's actually quite huge lah, the amount, the reduction amount. Okay, so and then if we compare about to the POMSI score, we can see previously the score is only 50%. So 50% if in academic will is like C, I think 50 is C. But then after implementation of these two mitigation, the score increased to 100%. Okay, so would say it shows that this I would say the implementation of this mitigation is very good lah. Okay. However, you can see but we need to also analyze in a term of the total cost lah. Okay, in the total cost performance. So previously the total cost performance is 91%. But if we implement it, the total cost will slightly reduce like to 85% the score. So in the terms of RM in a ringgit Malaysia, the total the production cost will be from 49. It will slightly increase to 49.03. But this is just a rough, I would say rough calculation for to just validate the results. I think that further we need to also consider any other factor lah for the cost, because I think this one is only for the first year running of the implementation, but then later on we also need to consider the analysis for upcoming year. Okay. Because if you know that for the biogas we can still if not mistaken, we can sell the product from I mean the biogas and something like that. Okay, so that they can also create some revenue lah to the industry. Okay. Right, and then we move to the scenario 2, which is on we only implement the biogas. Okay, we can see that the total reduction of the POMCFA is from 13.82 to 11.02, and also the total POMSI is 50 to 100. And then the total cost performance, I think quite similar with the previous one. And lastly, the production cost is from 49 to 49.02 lah. Okay, so I think there's 0.01% difference with the scenario 1. Okay, let's move to the last scenario, which is we only consider the wet scrubber. So for this one, I would say that the POMCFA slightly reduced also from 13.82 to 13, but for the POMSI score, it will remain the same from 50, which is 50%. So as we know that the wet scrubber cannot help in terms of improve the mixed raw effluent. MRE is a mixed raw effluent. So yeah, that's why the score of the POMSI is remain the same. Okay, in terms of the total cost performance, it's from 91.07% to 90. So slightly reduced lah. Okay, then also the production cost is slightly increased by 0.01. Right, so based on these 3 scenario, actually it can help the user or maybe to the plant manager to make an to have to help them to have like a overall overview about the before they making a decision. So from here we can see that maybe from the scenario 1, the reduction of the CO2 is quite huge, and then for the POMSI also increase very huge increment, something like that, but might be increase a little bit of your cost of the production lah. So it's actually depends on the the direction of the plant and also direction of the company, which scenario will suit them best lah. Okay, so the games only help you to decide the best alternative, but for the final decision will be should be aligned with the direction of your organization. Okay, I think so we came to the conclusion. Basically, would like to highlight that this model actually help to oversee the comprehensive analysis for mitigation planning. It will help, as I mentioned, it's now it help the user to do the decision making. Okay, and then lastly, it will improve the performance of the palm oil production, especially with optimal solution. Indirectly will help to achieve your net zero emission as well, because if you set for example, if you set that you want to, like for just the example that I show you just now, you want to set the emission should be to set the emission, to reduce the emission. So actually is indirectly will help you to achieve the net zero emission goal. Okay, okay, next, if you are interested to read more on this study, you feel free to browse this title, then you can have the reading about this study. All right, I think this is all from me. If there anything from the audience, will open the floor for the question lah. All right. Thank you.
Thank you so much, Dr. Nabila, for such an intriguing and also such an insightful presentation on your paper. So there's this, I think from your opening introduction to your presentation, you mentioned how the current certification scheme are leaning more towards their economic enhancing economic operation, right? If I'm not mistaken. So I think my question would be, how does the model balance environmental sustainability with economic viability for palm oil producers?
Okay, I think okay, thank you for the question. I think yeah, the usually the main concern from the industry always on the dollar and cents. Okay, yeah, they want to reduce the emission, but still they need to consider about the cost and everything. So actually, it's actually to answer your question, it's actually goes back to your model objective and constraint. Um, so how do you decide your what we call your objective and also your constraint? The decision of the a good equation will represent a balance of every aspect lah. Okay. For example, if you mention just now my objective is to minimize the cost, so okay, so then so that's the direction of the company. But for example, if the company want to add that their budget is only in a certain limit, then they can also put that in their constraint. So yeah, it can be, I would say, tailored to the needs of the I would say the organization. Yeah.
Okay. Thank you so much, Dr. Nabila, for the answer. Now we have quite a lot of questions here from the attendants of this webinar. I think we're all quite excited to learn and also to hear your answers. So I think I'll read this question by Dr. Naesh from CNG Analytica of Malaysia. To what extent this mitigation strategy model takes into consideration of critical sustainability standards such as RSPO or National Sustainability Certification Factors, which indirectly address EU regulation in promoting sustainable palm oil production and combating deforestation. Dr. Nabila, maybe you would like to respond to this question?
Okay, to answer to that question, either the model is aligned with the, I would say that one is like a standard, something like that. Yes, we do include in our model. I mean, we consider the RSPO guidelines. I mean, in our assessment itself, like for example, for the POMSI, we already set our standard based on the regulation, based on the standard, and also based on the sometimes based on the company or the organization goal or something like that. Yeah. To answer that, yes, we do include that in our study.
Okay, so the RSPO and other certification standards are taken into account when signing the model, right? Okay, so I think we can move into the next question by Irdina Adami. So Miss Irdina asks if she may know the CO2 reduction is based on scope 1 solely, or does it also cover scope 2 emission?
Okay, thank you, Edina. Okay, so for your question, actually, for the POMCFA calculation, we only use like the what we call emission factor. So that's why I represent it as a CO2 equivalent. So we are not doing like I would say like very extensive calculation. I mean to consider which one is scope 1, scope 2, and scope 3 of the I mean from the plant or oil mill. We just use the emission factor to represent it as a CO2 equivalent. But I think it's a good suggestion. I think maybe it's a good future work later on. So we can like do a like more detailed study on the POMCFA part. So then we can have like more actual I would say estimation of that plan lah. Yeah. Rather than we just use the emission factor, it might reflect like less accurate value. Yep. Okay, thank you, Aidina. Yep.
Thank you so much, Dr. Nabila, for the answer to Ms. Idina. So we will move on to another question by Bahauddin. The person asks, with the increase in population, there has been a huge demand for palm oil as an edible oil. So the producers are increasing their production, or which along with it, various technologies are being used. How is it possible to achieve net zero emissions when technology is moving at a higher rate? Okay, maybe Dr. Nabila, the floor is yours to answer.
Okay. Actually, I don't quite get your question. But okay, let me rephrase it with the because I'm currently reading the question. Okay, so
Okay.
the increase in population, there has been huge demand for palm oil as and edible oil. Okay, so the producer are increasing their production along with it. Various technologies are being used. How is it possible to achieve net zero emission when technology is moving at a higher rate? Um, Actually, I don't quite get your question, but this is my understanding. How is it possible to achieve the NZE when technology is moving at higher rate? I believe that in current, I mean in current uh, uh current trend now, if any technology development, they will always consider NZE in part of their development lah. So I think it's possible to achieve the NZE or is it you mean the technology is moving at higher rate? It's like production is in a more I mean it's a more higher production. It's something like that. If in that case, for example, if the production is getting bigger, getting higher, so that's why we need to have this kind of model um um to help us to decide which mitigation can help us to reduce the emissions, and then also to help to improve their sustainability performance. So indirectly, by having that, by implementing all those mitigation option into your current plan, so it will help you to achieve the net zero emission. I hope I'm answering your question. Yeah.
Okay, thank you so much, Dr. Nabila. Now, I think I will retrieve one more question from the Q&A box. I think I will ask you to choose, Dr. Nabila, which one will suit your mood today.
Okay. Okay. One. I choose how many question? One.
Yeah, one for the Q&A
Okay.
box, sadly due to the time limitation.
All right.
Yeah.
So I think okay. This one. Is there any prioritized mitigation strategy that could effectively reduce emissions? Okay, so in the early stage of the model development, we will not I will say uh just select the what we call the one that will reduce the most of the emission, because sometimes the technology can impact expect differently to the other indicator lah. So we will try to gather as much as possible I would say information or data to be kept into our database. So then after that, then we let then we let the model to decide it for us. Okay, because for example, if you already decide, okay, this one is will reduce the most I would say the emissions, but then the cost for their the cost of the implementation, cost of the to operate it using that technology might be so high that the plant cannot cope with it. So yeah, that's why we need to just gather any relevant mitigation or technology option to the to palm oil mill, and then using our mathematical equation, we set our constraint, we set our objective function, then after that we let the model decide it for us lah. Yeah.
Thank you, Dr. Nabila, for the answer. And maybe this one last question, Dr. Nabila. The question is from me. So, is this model applicable for all ASEAN countries? And if not, what is the crucial consideration based on that should be put into the model to describe a certain or a particular country's special condition?
Okay. So to answer your question, Vera, okay, absolutely, yes. We can. This model is applicable for any countries actually. Okay, so if we're talking in general settings, yeah, this model can be ready to apply to for any Asian countries. But if you are looking into specific requirements, for example, if you want to look into a geographical factor, weather, climate, and something like that, so then we need to customize it a bit lah in terms of the mathematical equation. But yeah, in the general, yeah, it can be applied to any Asian countries. Yeah.
Okay. Thank you so much, Dr. Nabila. I think because we have such a very limited time, which is very unfortunate. It's been very insightful to hear from you and about your work. And it's very exciting to hear and to learn that how the palm oil industry and also our sustainability standards and targets are reconcilable and are not mutually exclusive here. And I think I will close the session by concluding some of the discussions and also the points from your presentation. So I think the model helps to provide analysis on mitigation planning, support decision making, and the optimization to achieve net zero in the palm oil industry. And that the best technology is one of the best technology is to have the biogas plant and with scrubber to support the GHG emission reduction in the palm oil industry in Malaysia. However, it also depends on the financial aspects to adapt the technologies simultaneously. And from the discussion, it is also very important to set a clear standard for the technologies that is still in alignment with the regulation. And therefore, it's very evident that instrumentalizing a holistic model by integrating carbon assessment and sustainability evaluation is important as an initial assessment before determining the best strategies to reduce GHG emission in palm oil industry. And as our discussion draws to a close, let's remain committed to fostering collaborations, sharing best practices, and advocating for policies that promote both environmental stewardship and economic prosperity. And together, we will also hear from Dr. Nabila for your closing remarks, for anything that you would like to say to the participants regarding the model and also your work.
Okay.
Please,
Right.
Doctor.
Okay. So first of all, I would like to thank first lah to the ACE for inviting me for this opportunity to having to share my recently article in this ARNECC Paper Talks. I think this is a very good initiative. So we can share our research with other participants. So yeah, I believe that this model is actually it's a comprehensive way and also to help the industry to achieve their net zero goals lah, or specifically. But I would say that there is a lot of more extensive work to I would say to make the model uh, to make a much more perfect model, which is we can look into like previously we do the technology review manually. So maybe with the current, I would say, trend right now with the AI and something like the machine learning, we can integrate it in our work lah. So I believe if there any participant here that also working in the same area as me, maybe we can connect and maybe we can link maybe the ACE can link us together, then we can collaborate and maybe we can work together to I would say for the future of this research work lah. Okay, I think that is all for me. Thank you for all the participants and also especially to Vero for hosting our session today. Thank you for your time. Thank you for your commitment for attending the session and attending my talk. Yeah, see you soon. All right. Thank you.
Thank you so much, Dr. Nabila, and it's a very heartening to hear such a call for networking. Yeah, maybe the experts in the region can also collaborate on this specific topic and propel the palm oil industry forward for a more sustainable future. And yeah, to conclude today's session, I would like to say together, collectively as ASEAN citizens, we have the opportunity to shape the palm oil sector that not only mitigates its carbon footprint and also take into account the economic aspects, but also prioritizes social responsibility and environmental conservation. And lastly, I would like to once again thank Dr. Nabila for your valuable time, for your insightful presentation, and also your comprehensive answers to all of the questions here for such a meaningful discussion, dialogue. And thank you for all the participants for your thoughtful contributions and also attendance to this event. Once again, thank you very much. And with this, I will close this event. Thank you so much.
Bye bye.
Bye.